Now we have Maximilian Roth. Maximilian is the business development, leads the business development for the new LPWAN standard Mioty at the Fraunhofer-Institute for Integrated Circuits IIS and in the Mioty Alliance. Maximilian.
Thank you.
Thank you.
Hi everyone, my name is Maximilian Roth, and today I will present you a quite new low power wide area network technology which is called Mioty. And I will show you in this presentation why we believe that this technology will have a huge impact on IoT. And before that, I would like to give you a short introduction to the Fraunhofer Gesellschaft, which is the inventor of this new technology. And Fraunhofer is, for those who don't know, the world's leading organization for applied research. And the team behind the Mioty technology is from the same research institute which brought you things like the audio codec MP3, for example, or DAB+. We have several research areas there around IoT. For example, we are developing smart sensing technologies there, positioning and localization technologies, but also communication systems, such as, for example, 5G, 6G, but also satellite IoT, or also low power wide area networks. And I'm aware that a lot of experts are here, and we have heard also a lot of different presentations about that. Therefore, I would like only to give you a short overview about this technology. And I will present you some technologies we see here in this field today. Well-known technologies are Sigfox, for example, which was recently required via UNABIS. We see LoRa, we have heard a presentation about it before. We see narrowband IoT, LTE-M, and in this matrix on the right side, you see a comparison of these technologies by public versus private networks, open standards versus proprietary technologies. And in addition, a new technology has joined the LPWAN market currently, which is called TS103357, or much easier, Mioty. Mioty is open ETSI standard and is currently deployed mostly in private networks. But we have also installation in public networks currently. Mioty works for scenarios where you need ultra-low power and where you need lots of sensors. And these are criteria or performance indicators which are critical for IoT and which will become even more important in the future. Let's take a look at some future developments here. We have heard already some of the market figures. We all expect that this market will increase tremendously, significantly. There will be up to 3 billion devices connected in the future, and it's about 10% of the overall IoT market. These devices will be deployed in different verticals, for example, in utilities, in logistics, in smart cities, or in buildings and industrial IoT. But when you connect billions of devices, you will also face a huge challenge in the future. The challenge will be that these devices will connect to each other, and the spectrum will become very crowded, and we will see interference problems, and we will see loss of information. And therefore, it's important to have complete new technologies on the market which can scope with this massive devices in the future. And exactly here we have seen some limitations from existing technologies. And this is what I will show you right now. On the left side, you see how is data transmitted currently. You have a whole telegram which is transmitted but if only one part of this telegram is interfered, you will lose your complete message. And to overcome these limitations, Fraunhofer has developed a complete new technology for wireless communication, which is called telegram splitting. And we divide the telegram in short subpackages and distribute them via time and frequency. And the advantage is that you get a very good interference immunity, because we need only 50% of these subpackets to reassemble the data in the base station. You have some more benefits to this. You have a good coexistence efficiency. You have a very good power efficiency, but also a great reliability with this technology. And some of these benefits I will present you now in comparison with other low power wide area network technologies. Let's start with long range. Here you see a network planning for OMS. The yellow pin is here the base station, and barely visible in green, you see the coverage they have, so which is very low. So if you compare it with existing LPWAN technologies, the range will become much higher. And it will be significantly higher with Mioty, as you can see on the right side. Now it's possible to transmit 3.5 million data points, messages per day with less than 1% packet error rate. We transmit this data very energy efficient, and here you see a comparison of the power consumption of different LPWAN technologies. Mioty transmits the data with 90 millijoule, what is very low. We also using energy harvesting, for example, photovoltaic, but also vibration harvesting, or also thermoelectric, for example. And the advantage is that you have low cost because you need much less batteries, and the battery lifetime is much more longer. And from a sustainability aspect, it's also better, of course, if you need less batteries. The third criterion I would like to explain a little bit better is reliability. We made tests with Mioty where we installed different sensors in the cellar and in three different locations: in a shopping center, in an old bunker, and in an abbey. And as you can see, the test was very good for all LPWAN technologies. We transmitted 10 bytes data every 10 minutes, and all delivered their telegram very reliable. The challenge comes in if you have complex sensors in the field, for example, water meters, where you need 200 bytes of payload, and then it's really challenging to transmit the data out of the cellar. And we could prove here that Mioty transmitted this data every 10 minutes over a period for 14 hours, very reliable. But of course, it's not only about the technology features. We're also talking about cost efficiency, total cost of ownership, when you are choosing your LPWAN technology. And here you see implementation of an area of 12 square kilometers. We have we needed 40 base stations here to really cover this complete area, deep indoor. And we did the same with Mioty, where we needed only 20 base stations, 50% less. And this means you had a much better installation or lower installation and maintenance costs with this technology. Let me sum it up. Mioty is long range. It's working for 5 to 15 kilometers, depending on the environment. It has ultra low power, up to 20 years battery lifetime, depending on how often you send the battery, of course. High reliability, interference immunity, and also a great scalability and capacity. And you can use this technology not only for stationary applications, where you install a sensor on a wall, for example. You can also use it for mobile applications Mioty nodes operated up to 120 kilometers per hour. We were also talking about the left side, the economic benefits, lower CAPEX and OPEX, but also about an open standard. Mioty is a ETSI standard. It's open for everyone. There is no vendor login. And you can use this technology worldwide. It's in the frequency bands 133 and 966. You can operate it as a private network. Therefore, it's called actually Mioty, my IoT, my Internet of Things. Or you can also integrate it in public infrastructures. And the last point is now very crucial. It's future-proofness. Mioty is a software, and you can integrate this technology on every FSK transceiver, which means that this is completely hardware agnostic. Well, we were talking now about only the communication technology, and we all know that it's not enough to really generate benefit at the end customer if you have only a reliable communication technology. You need much more. You need smart sensors, you need base stations, you need hardware providers, you need an IoT platform and so on. And that's the reason why we have founded the Mioty Alliance 2 years before at the Embedded World. And we started with 8 companies and have now grown to 40 members. It's a wide range of different companies there. We have chipset manufacturers such as Texas Instruments, ST Microelectronics, or also Scilabs. But we have also specialists for industrial IoT applications, such as WICA or IFM, smart metering manufacturer, but also experts for example, critical infrastructure like Swissphone, or a provider for network and application management like Loriot. These members are in these verticals active, where we have several projects, but the most projects we have in industrial IoT, for example, in automotive at BMW in Munich, but also in Mexico, in steel, in mining, for example, but also in the process industry. We are into smart buildings, but we are also in smart cities, of course, especially in the metering industry. And our members provide these verticals different hardware solutions. And actually, I'm very delighted to present you this snapshot today, because when we started 2 years before, we had 1 base station and around 5 sensors. And so let me give you at least a short overview about it. On the left side, you see different sensor IoT platforms such as TI, ST Microelectronics, Scilabs, but it's also running on Semtech. The Mioty technology, you can use it for unidirectional transmissions, but also bidirectional. You can also combine different LPWAN technologies in software stacks, and you can also add, for example, short range like Bluetooth to configure devices, which you see here in the third column. And these devices send the data to our base stations. And what's here very important, that the newest base stations are so-called multi-protocol base stations, which means that we can receive different protocols out of the LPWAN field. And this means for the end customer, he can use several technologies now in parallel. As I said, I wanted to give you an overview about some use cases also. For example, you see here smart metering projects, for example, in Germany, but also in Austria. And we have several rollouts there already, which will be announced in 2 weeks at the Embedded Fair. The most of the projects are from deal metering, and some of these projects you see here on the bottom right. Most of the target customers are municipalities, but we have also airports as customers. for example, the airport in Munich. And the challenge they have is that they have to connect thousands of water meters, for example, from different manufacturers. They are distributed in a cellar over an area of 15 square kilometers. And it's a huge effort for them to get this data manually out of the cellar. And therefore, we deployed a network there, and Mioty network together with our partners, and realized a complete wireless infrastructure. We send all the data to the base stations, and it's not only like new smart sensors. We did also retrofitting, for example, with these sensors. But the most important point here is that we only needed 3 base stations to cover this complete 15 square kilometers, completely deep indoor. Next steps are that we will expand these use cases, and we will also get new features into, we test new features. We will have a new revision of Mioty, we call Mioty 2.0 for ETSI, where we will get even more data rates, but also new functionalities, such as, for example, broadcasting or multicasting, because you don't only want to receive the data, you will also want to control the devices in the field and address the complete devices at once or only partially some of them. Well, I'm coming to an end with my presentation. I hope I could gain some interest here for the Mioty technology. I have no booth here, so if you have an interest, please visit me at the IoT Hub booth here later. Yeah. And now I'm available for questions if there are any, and as long as if they are not too technical. Thank you very much for listening. Thank you.
So, questions? Yes, I imagined.
Yeah.
Yeah, sorry, I have to ask that question. Yeah. You were showing on the comparison LoRa as a proprietary technology. I just want to say that the LoRaWAN standard is an open standard and has been authorized by the ITU early this year. So I think the position as a proprietary technology is not entirely correct. But the question here is, what is your licensing model? What's the business model of Mioty if it's just software?
First, regarding the first question, though, it is correct, because LoRa is a proprietary technology. LoRaWAN as another layer, as a higher layer, is standardized by ITU. That's correct. And regarding the license model, that's an easy one. We are licensed this technology via Syswell, which is our patent platform we have founded, and you can see it in the internet. It's completely available there. The license conditions are under FRAND conditions, fair, reasonable, and non-discriminatory pricing, and start at 16 cents for a one-time fee.
Thank you.
Thanks.
Okay, thank you very much, Maximilian. And now we can leave for the lunch. It will last 75 minutes, so you are welcome back in 75 minutes. Thank you.
Thanks.